Right. Now we are going to do a conversion the other way around. Now earlier the previous examples were converting a decimal number to binary. So now we are going to see, take a binary number and we are going to convert it into decimal. So let's look at an example. So see, I have put the 2 here to show that this is not 1001, this is a binary number. I want to see what is this in decimal in our usual number system. What does it do? So how do we work out this? To do this, what you do is you put again the line, and how many digits are we having here? 1, 2, 3, 4 digits. So we need to put weightage only for 4. Okay, the 1, 2, 3, sorry, and 4. Okay, so 1, 2, 4, 8. 4 digits enough. 4 weight is enough. Why? Because we have our number is only 4 number. Then we put those numbers here. This last digit you put on against 1. Then the next one, this 0 here. This 0 we put here, and this one we put here. Okay, so 1, 0, 0, 1. 1, 0, 0, 1 we are written on top of the weight. Okay, weightage. Next, you calculate 8 into 1, that is this one. Okay, we are taking 1 8, so 8 ones. These two are zeros now, so you don't have to actually write those. We are not taking any 4s, we are not taking any 2s, but we are taking 1 of 1, so that you put here. Okay, and then you have 8 into 1 8, 1 into 1 1. When you add these two, the answer is 9. So the binary number 1001 represents our usual number 9. Okay, so 1001 binary is equal to 9 decimal. Decimal, you don't have to put the subscript. Okay, because if the subscript is not there, we assume the number to be a decimal number. Okay, again you can either write it as with 2 or the B. Another example. Now we are going to convert 1010, again binary number, to decimal. Same way, you put the line and the weight, and how many weights we need? Only 4, because this is 1010, 4 digit. Okay, so we put 1, 2, 4, 8, multiples of 2, right? And 4 is enough because only 4 numbers are there. Then we put the last digit here, 0, the next digit here, okay, the next 0 here, and this one here, in this order. Always start this last number with the 1 and come this way. That's the easiest way to do it. So now what do? We work out this 8, 1 of 8, and like I told you again, 0 we don't need. We are not taking any 4s now, so that is 0. So 4 we will not use, but 2 we are using 1. So you put that here, 2 into 1. So 8 into 1, 8 plus 1 2, 2 into 1 2. So these two added. This is 0, so we don't need to represent this or this because both are zeros. So this you add up and the answer is 10. So the binary number 1010, it represents the decimal number 10. So you can write like that, okay, or with the B. Okay, understood? So now let's take a look at another example. This time a bigger number than the previous one. So this time we have 1001110. This is a binary number. Okay. Remember, binary numbers cannot have any other digits other than ones and zeros. So this is a valid binary number. It can't have any other number. This 2 is not part of the number. This 2 is just to show that this is a binary number. Okay. This 2 is just a, or you can put B. It doesn't matter. Anyway, we are trying to convert this binary number to decimal. Again, let's see. We put this and we want the weight starting from 1 and multiples of 2. How many digits we need? 1, 2, 3, 4, 5, 6, 7. There are 7 positions here. So we need 7 weight. So 1 multiples of 2. 2, 4, 8, right? 16, 32 and 64. After you take the 64, you take this first number, the last digit, and put it against the 1. Then you take this one, put it against this. Take the next number and put it against here. Take this one and put it against here. Okay. take this 0, put it here. Take this 0, put it here. Take this 1 and put it here. Okay, so we have the digits, this exact number put against the weight of the binary system. Now you calculate how many 64s? 1. So we are using that. 32 and 16 we don't need, because both we are not taking, we are saying zeros. So anyway the answer will be 0, so we can ignore that. But 1 8, so the next thing will be 1 8. Then 1 4, that is this. Then 1 2, so 1 2 here. This one ignore, 0 1s, no. So this is all we need. So when you add those 8 64 and 8 plus 4 plus 2, the answer comes to 78. So the binary number 1001110 represents 78 decimal number. That's our day-to-day number, that number we are familiar with. 78, if you want to write in binary, this is how you will be writing: 1001111 and 0. Okay, so here we are showing the binary number equals to 78, right? Or you can write instead of the 2 with the B. Both are same. Okay, right. So let's now just see how to write numbers. Let us write some decimal and equivalent binary numbers. So I put a small, this is to put my weightage. So let's put the weight as 1, 2, 4. This is the binary weightage, right? Multiples of 2. Then 8, then 16, then 32, then 64. Then if there is another one, it will be 128, then 256. It will just go on like that. Okay. So now I want to write the decimal numbers here and the binary numbers here. So let's start off with the 0. Decimal 0, how do you write in binary? No problem. Binary number has 0. It has 0 as well as it has 1. So you can just go ahead and put the number here. 0. Oh, decimal 0 and binary 0 are same. There is no difference. Now we'll go to the decimal 1. How do you write in binary? Same. Binary number also has 1. So no issue. Next is decimal number 2. Decimal number 2, how do you write in binary? Well, now we have a small issue. Why? We can't put 2 here, no, because binary number has only zeros and ones. So we want 2. What do? We can say, okay, we want 1 2 to take that, and no zeros. Okay, sorry, no ones. We want 1 2, then we have the 2, and this will be 0. So 1 0 will be 2. Okay, so decimal number 2 is written as this. 0 and 1 are both same. Binary number and decimal number looks the same. But the moment you go to 2, since binary number doesn't have 2, binary number has to use a combination of ones and zeros. And how it uses? Using the weightage. In the weightage, this position says 2. So 1 2 and 0 ones adds up to 2. So the 1 0 means 2. Okay. So now let's go to 3. How do we write 3? 1 2 and 1 1. So 2 plus 1, 3. So 1 1 will be 3. Okay. Let's go to see how 4 is done. 4, how do we write? Okay, we put 1 here, that is 4. So we have used the 4. We don't need 2, we don't need 1. So 1 0 0 is 4, binary. It looks like 100 in decimal, but this is actually not decimal number. This is a binary number. Now I put this heading. So binary number 1. So 4 is written like this in binary. Now let's see 5. 5 will be written as no 8s, right? We can have 1 4. Okay, we have 4. Can we have 2? No. Why? Because the moment you have a 2, 1, then it will be 6, no? But we are trying to get 25. So we put 0 2s, but we want 1. So 4, 1 and 1 1. 4 plus 1 is 5. So 1 0 1 represents the number 5 in binary. Okay, now let's go to 6. How do we write 6? 6 again can't use 8. We put 1 4 and 1 2. That is 4 plus 2 is 6. We don't want any more numbers, so 0 here. So 1 1 0 will represent the 6. Okay, so let's see how 7 is represented. If you want to put 7, again you can't put 8. We put 1 4 that is 4, plus another 2 can, because then it becomes 6, plus another 1 becomes 7. So 1, 4 plus 2 plus 1. 4 plus 2, 6. 6 plus 1, 7. So 1, 1, 1 is 7 in binary. Okay. Right. Now let's see 8. If we want 8, no issue. Now 8, of course, we have a number. So we will put 1 here. So the moment we put 1 here, we have used up the 8. So no more any other, these numbers can't be there. Because if you have a 4, it will become 12. 1, 8 and 1, 4. So we have to put 0, 0 and 0. So 1 and 3 zeros will be 8 in binary. Right? Then let's look at 9. 9, okay, no 16, can't have 16, no, it's the number is less than that. So we have to have 1, 8 and 1, 1. So no 4s and no 2s, but we need 1, 1. So 8 plus 1 is 9. So 1, 0, 0, 1 is how 9 is represented in binary. Let's see 10. 10 in decimal. Okay, these columns 10 are decimal. 10 decimal, again we will say 1, 8. We can't have 4s. We have 1, 2. So 8 plus 2 is 10. So we put 0 here also. So that is how 10 in binary is represented. Okay, let's go to 11. Okay, 11. How do we put 11? Okay, we have 1, 8. Can't have 4. 1, 2. So 8 plus 2 is 10. Plus 1 is 11. So 1, 0, 1, 1 will represent the binary 11, right? Okay, 12. 12, how do we do? 1, 8 and 1, 4. 8 plus 4 is 12. So we already got the number. So the rest of them will be zeros. So 1, 1, 0, 0 is how you write 12 in binary number. Okay, finally we'll look at 13. For 13, can't have 16 no, because it's a smaller, lesser number than that. So 1, 8 plus 1, 4. So 8 plus 4, 12. And we need 1 more. So we can't have 2. We can have 1. So 8 plus 4 is 12. Plus 1 is 13. So 1, 1, 0, 1 represents 13. Okay. So what I want you to do is, you do your numbers. Now we have gone up to 13. So try and see whether you can work out 14, 15, 16, 17 and just keep doing that. If you can say maybe about 15 up to 50 or something like that, and see whether you can do this conversion. Okay. So in the meantime, after giving you some time, I will put these values in the group slowly each time, each number. Okay. Then you can check those and work through. Thank you very much for watching this. So we'll catch up with in the next video.